Hello everyone, my name is Dan the Tutor. This is a clip from one of my weekly group tutoring sessions at the University of Delaware for Physics 201. If you have any questions, please leave them in the comments below. Thank you and enjoy.
Okay, next up, this is still going to be work and energy. This time it's going to be the work side. How work ties in with energy, that is. So let's say I have a box sliding across a surface here. The box is sliding with a speed of 8 meters per second. And ultimately, it's going to be coming to a stop. Why? Because I am sliding this box across a friction-filled surface. Like, there is friction. There is definitely friction. I'm going to give you mu k is equal to 0.2, let's say. And again, no units for you mu k. No units. So what I ultimately want to find is, this thing's going to come to rest. I want to know how far it travels. What's that distance traveled right there? And I need to give a mass, let's say 3 kilograms. 3 kilograms. Okay, I think that's all I need to give you for this problem. Now, one thing I do want to mention, this looks like a force problem. Why? Because I gave you a coefficient of kinetic friction. We know, based on that other problem, that the equation for friction is equal to mu k times the normal force, and that looks like forces, right? This can be a force problem. However, this can also be a work and energy problem. Why? Because I'm looking at 2 points in time. I'm looking at this point right here, and I'm looking at this point right here. So this can also be work and energy. And I'm going to tell you right now, work and energy is 100 times, I don't know about 100 times. It's at least twice as easy as forces. Because if you solve for forces, ultimately you're finding acceleration. You have to do the free body diagram. You have to do the sum of forces equation all over again. And then this actually turns out to be kinematics. Why? Because the only way you can find distance is if you use kinematics. Now, you can use that if you want. You can use forces and kinematics, but I'm going to be teaching you how to do it using work and energy because, well, that's why we're learning it, so we can avoid force and kinematics in situations like this. Okay, so if we think about this, number one, is energy conserved? Is energy conserved? The answer is no. Why? Because I have friction. I'm even going to write that. Energy is not conserved. And again, we know that because there's friction. So what does that mean about the equation? Well, the equation's no longer E total 1 equals E total 2. Now it's going to be E total 1 plus my work is equal to E total 2. And again, the work is the work done by friction. We have an equation for work too. We know work is equal to a force times a distance times, well, cosine theta. But remember also what I said. You can remember this shortcut. Since it is friction, it's going to be negative Fk times d. Everyone remember that? And again, it's negative Fk times d because cosine of theta, the angle is 180. The angle is 180, and cosine of 180 is negative 1. Okay, so now let's think about what kind of energy we have at point 1 and point 2. I'm looking at my picture. I see that there's no height, so I don't need to worry about that. There's no spring, so I don't need to worry about that either. At point 1, there's only one kind of energy. It's kinetic energy, because there's a velocity. So my energy at point 1 is going to be 1/2 mv squared. I then add, I'll just say work for now. We'll solve it later. And that equals E total 2. I'm looking at point 2 now. It doesn't have a height. It doesn't have a spring anywhere. So it must be kinetic energy, except for the fact that we know what the speed is at point 2. What is it? You can call it out. I know you know it. It's 0. Velocity is 0 at point 2. Or maybe you had a feeling it was 0, but you were too afraid to say it. Why is it 0? Because it's coming to a stop. And because of that, there's no energy at point 2. I repeat, no energy, which means E total 2 is just 0. And that is possible, especially when there's friction involved. Especially when there's friction involved. Okay, great. So now, we have 1/2 mv squared plus w equals 0. I'm going to solve for w real quick, because then I can plug w in right there and ultimately find this distance d, which is what we're solving for. So w equals negative 1/2 mv squared. I just subtracted 1/2 mv squared from both sides. I'm going to plug in work equals negative 1/2 times mass is 3 times velocity is 8 squared. It's going to be 64 divided by 2, which is 32 times 3. Negative 96. I just want to make sure that's right. Yes, great. Negative 96. And the units for work. That's right, they're joules. Capital J. Okay, so we have our work. Work equals negative 96. Again, I'm setting work equal to negative Fk times d because that's my work done by friction. So work done by friction is negative 96. I have an equation for Fk. I have an equation for frictional force. Fk equals mu k times the normal force. Man, this problem just gets longer and longer, doesn't it? Well, luckily I gave us mu k, that's 0.2. Now, what's the normal force? I'm going to scroll back up to my picture. What is the normal force? Think about this. Am I on an inclined plane? No. Is there any other forces acting in the y direction? No. So if I were to think about a free body diagram here, which again, even though this is not technically forces, you can see that forces does play a role, especially with work. Now, normal force points up, mg points straight down, normal force cancels out with mg, which means that my normal force N is equal to m times g, which is 3 times 9.81. So Fk, my friction force, equals 0.2 times 3 times 9.81. Let's plug that in a calculator. 0.2 times 3 times 9.81, 5.886. So that's my frictional force. And again, I'm plugging that in right there. So I'm saying negative 96 equals negative 5.886 times my distance d. Only one thing to do left. Divide both sides by negative 5.886. And we will get a final answer of 16.3 meters. Very cool. And that's the answer to this last work and energy problem. So again, what's the strategy for work and energy? Well, first of all, remember how I said at the very beginning, you need to be able to identify work and energy problems. Work and energy is the hardest one to identify because, I mean, having 2 points, it's not very obvious when we have that. It's not like, well, with forces, you see a pulley, you see a ramp, you probably know it's going to be forces, or it says forces in the problem or something like that, or newtons or something. With work and energy, sometimes they don't tell you work or energy. You just have to kind of get a feel for it when you would use it. And I mean, that just comes with practice. There's nothing else I can say about that. But once you identify its work and energy, the next step is asking yourself, is energy conserved? In this example, energy was not conserved because of friction. And so then we used our equation, which is this one right here. E total 1 plus work equals E total 2. This is, I mean, if I were to make a list of the most important equations for this test, I already said 2 of them already. What was it? Friction. Friction was one of them. Fk equals mu k times normal force N. And then I also said work is super important to know, which I have both of these actually on my screen right now, so I'll just circle these. Yeah, these, if there are some equations that I would have on the front page of your equation sheet, it's these 3 right here. Any other ones that you want to put on there, go ahead, but these 3 I would absolutely have. And you may be probably wondering, oh, Dan, can you please make us an equation sheet for you guys? And had I prepared a little bit better and thought about this, and even so much as an hour sooner, I probably could have done that for you guys, but I think at this point it's just too late. So I'm just going to tell you the equations I recommend memorizing, and I think you're going to be okay with that. If not, then, you know, I mean, I'm doing this for free anyway. What do you want from me? Okay.
Don't forget to like and subscribe. If you want me to start doing free weekly group sessions at your university, please post in the comments below or email me at dan@danthetutor.com. Thanks, everyone. Bye-bye.